switch on your mic and let me know if I'm not clear by any chance. Yeah, so I think today's session is going to be purely around looking at the software engineering side of things, especially um, the version control, CI/CD, and Docker, which is quite critical when it comes to sort of building AI solutions. And I think like this is can be quite easier for somebody who's coming from a software engineering background, but for someone new, it's going to be quite critical because it's really important that you understand these concepts. And because that's going to help you build like really good software and like have like maintainable software. And you can work with teams like with GitHub, with collaborations, etc. So you're going to try and focus on this today. This concept that is needed, like which is not flashy, but like it's quite critical. So today's focus is predominantly around how code is managed. So when you use things things like GitHub. So how do you manage code with tools like Git and GitHub? And then how do you sort of ship codes? Like how do you do automated testing? How do you do automated deployment? All kind of stuff. So it's the second point that you want to like focus on. And then how do you sort of standardize runtime environments, which is predominantly looking into Docker, and how do you sort of containerize your environment so that it can run anywhere. So that's the third point. We also got a bonus today, so it purely depends on the time availability. So if we run takes a lot of time, I might not be able to do that. I'll push that to next week. But yeah, it's going to be quite interesting, the last bit as well. Yeah, and feel free to stop me anytime, ask any questions. As usual, it's going to be this conversation that we sort of have rather than just me talking about a specific concept. Um, so I think like if you look at the main problem around like software engineering being the programming coding being on your sort of laptop, your machine, like how do you sort of make that production ready and how do you make that usable by other folks, and also how do you collaborate on like when you take like a larger software solution, it's not just you that is building the system. You need to sort of maintain, have other folks contributing to that, and also you have like quite a few variations of that because code changes really frequently, and with things like AI tools, like it's changes much faster, and sometimes you might not be able to sort of keep track of the changes because you're doing a lot of changes. So you're adding multiple features, things like that. And then another aspect is like the manual deployment side of things. Like, so for example, if you have to like make to go and like manually deploy software all the time to production, that's going to be a bit risky. And the other aspect is that the environments, so I'll go a bit more into detail in a bit. The idea being like the environment, the the environment that you have on your sort of computer. It's not the same as on somebody else's computer. It's not the same on a different server. So because of that, the software that works on your sort of computer may not work on somebody else's computer. So that's why environments needs to be consistent. So this is like very common issue, like maybe 10, 15 years back. So you have like all kinds of guides. So that sort of major issues, one of the major issues that's out there with software development. So addressing these things, like different concepts came up. So we'll go into a bit more detail on those topics today. So everybody knows Git, like we've used from the first week. I think like some may haven't used Git before, but like through this program, you managed to sort of work through Git. I think the concept behind Git, so it's a really interesting story, like how it started. So I think like this is something you should read about. Like before Git, there was Subversion, like all kinds of versioning control. The reason behind Git is predominantly around how do you maintain different versions of the code base, so that you have rather than you have something like final final Python file.py or final.python.py. So you could sort of maintain these versions, right? So because of that, so you got Git invented by Linus, I think. So the founder was Linux. Yeah, Linus. So he created this just to purely. He didn't like what was out there, the subversion system that he was using to maintain the maintain Linux code base. He didn't like that, so because of that he created this. It's like if you look into Git, it's a really interesting, like very pure, like really interesting sort of a software solutions. Like you have like these objects created, like you have tree of objects and you maintain different versions, like so the Git is like really interesting if you want to like dig deep into like understand software engineering, like because it's open source, you can read and understand that, and also you can use something like ChatGPT to like break like figure out like how Git works. But that's for the nerds out there, like go and like sort of spend a bit of time on Git. But I think like from a use case point of view, Git is amazing. Like so Git helps you to like keep track of code changes, helps you collaborate together. Like you can have different branches, like different people can work on different sort of features, and you can sort of merge them like few uh few iterations down the line. And also it helps you like do rollbacks, like if something breaks. It helps you to like go back to like sort of working protocol, so working version of the code base. So if you can see the right hand side, which is so if you've done like collaborative work on Git, you know, like sort of the Git merge could be a bit messy sometimes, like because like that could be a smooth merge, it could be merged with conflicts, then you have to resolve it. Like so I think like so many memes around this, like so how to sort of manage these, like working with like multiple users within the same code base. But the more you use it, like you'll find your own pattern, like you'll find like how to work within your team, because Git can be sort of um, like these features can be used in so many ways. And but the idea here is that you could sort of use Git as a way to maintain your code base and the different versions of it, and to collaborate with other code users. So Git is not the only tool out there, but it is the most commonly used one. And I think like it's fine to master Git, and I like I've rarely seen people use Subversion, like maybe if it's in an older on-prem system, that people use it. But Git is implemented in different ways. Like for example, Git within GitHub, and also you have Git with GitLab, Bitbucket. The concepts are everything the same, but the user interface and how you interact with it might change a bit. So that's the quick and very summarized way of introducing Git. So this is one example, like Git branching, which like the view of this is like you have the main branch. So you have the main branch and the feature branches. So the main branch is the actual use code base that you may have. And then you can see like at this point, somebody started like a feature. And when it comes here, somebody started like a relatively bigger feature, and they have added like multiple. So these dots means commit messages. So what that means like you done some updates and push that to the branch. So you call these are branches, which are deviations from the original code base, the version of the original code base. So when you're finished with this feature, you can sort of merge that to the main branch, and then you might find some conflicts and how to handle those conflicts, because like you might have edited certain files on your branch, where the main branch also might have changed those files. So you need to resolve those, but at the end of the day, it is like very sophisticated system, like a tool that helps you to like do this like collaborative exercise with other developers. So that's why Git, the branching is like a really strong solution. If you'd ever done open source, you definitely would have to use some of this. And the way you have to, for example, if you're adding a feature, you'll have a different branch for that feature with the ticket name or the issue name, and then you will have that branch name that you can sort of merge that separately to the main branch. So this is why I always ask people to contribute to open source. Like these kind of like skills can be automatically gained, because there's generally almost all the open source software to like organizations follow like the best practices when it comes to open source and the version controlling, etc. So this is like one feature of Git. Then we'll sort of talk about GitHub. So I mentioned like Git is being used by many tools, like Git being the foundational sort of technology, like the concept, and based on that, different people have sort of implemented that, and with a bit more customization, I would say. And so GitHub is like the most common and the prominent tool out there that has implemented Git. And it is not just the code repository aspect where you can save and have versions of your code, but it also gives you ability to collaborate and review your code with other folks. Like it's a much more sophisticated tool that helps you to have actual software development life cycle on the platforms. So it also has automated triggers like for automation, automatic integrations, automated deployments, and you also have things like Copilot. So I'll go into this link to show some of the tools that GitHub has. So if I go here, so yeah, so you'd have GitHub Copilot within GitHub because everything is owned by Microsoft right now. And then, so you have the collaborative coding aspect with PRs and branches, and then the automated integration and deployment. I'll go into that in a bit. And you've got project management. You can sort of have like a project management system within GitHub where you can have Kanban boards and task systems and everything. So this becomes like a fully fledged tool for engineering teams to build software, not just individual developers. So these are like where you sort of like one example of collaborations, like you have commit messages, etc. And like this is some of the other tools out there, like there's GitHub code spaces, like obviously pull request. If we do a change, you need to make a pull request so that that branch can be merged to the main branch. You could have code reviews, general discussions. So this is the CI/CD side of things. To webhooks, so you can sort of trigger, and you can do a lot of integrations as well. Like so, like for example, for deployments, if you want to deploy to like AWS or to Netlify, so you do automatically get built, the image get pushed, and then you can have that in production environment really fast. So that's why GitHub is quite strong. It's not just the code versioning aspect. So definitely most of these features are free. So definitely use that. So that like spend a bit of time, like for example, even um yeah, I think like it's like yeah, there's so many features GitHub has, but not everything will be used. But I think I'm using project management, I'm using CI/CD, I'm using also like quite a few integrations, like for example, Gemini, the if you take let me see if this is the yeah, so things like this. So this will help you automatically review your code and you add comments and all kinds of things like security vulnerabilities and generic like code review. So this is free to use. So you can configure your PRs and to automatically add comments as a like secondary sort of a engineer who's going to help you with your PRs. So there's things like this. There are quite a few tools out there so that you can use. Like offered through GitHub. So yeah, because of that, it's amazing. So I would highly recommend like spending a bit of time. GitHub also has like free resources for you to learn about GitHub, especially around CI/CD, etc. So I would spend a lot of time on that. Obviously, you can learn most of them as you build things, but also there's free resources that you can sort of try and learn while you are sort of yeah like it's free to use. So I recommend like use the GitHub learning tools as well. Then we'll talk about CI/CD. Just want to pause a bit if there are any questions around GitHub and Git. I mean, it's a relatively simple concept, but if you guys have any specific questions around that, happy to answer them. Everything's good. Cool. So we'll talk about CI/CD, right? Continuous integration, continuous deployment. So this is like an evolution of how we did things before. Like, so we tend to do some code changes, test it manually, and then sort of get it to production manually. So this is like obviously can cause errors, like because you tend to have human in the loop, and because of that humans can be sometimes inconsistent and you can make errors, and it could sort of mess things up in a big time. So, and also it's slow as well, so because of that, like you need people to review code, etc. So trying to fix that problem. So I mean it's not 100% fixed, but like you can sort of have this continuous integration pipeline. So what that means is like after your code, you added some new code changes and you commit that and you push that to the continuous integration pipeline. So you can set this up on GitHub side, that you automatically build your code, and you should have like a test suite, like that means like sort of unit test that runs against your latest changes, and then it will check if it's passing or failing, and then it will give you some indication, and then you have the integration test to see if all the components are working. So depending on how you set up the CI continuous integration pipeline, it will fail, or maybe if you have some level of tolerance for failures, it will sort of pass. So without this passing, you can't move to the next stage, which is the continuous deployment stage, where you obviously somebody will review this, and then you get it to staging and you get it to production. Sometimes you skip staging, you direct it into production. So the built image will be sent to the production environment. So this will be automatically done. You don't have to manually upload the images to the production environment. So you can set this up through GitHub. So this is the value of something like CI/CD. The software development cycle is much faster. So that applies for generic AI engineering as well, because it's purely software engineering based. So this is quite important. If you have come across this, I've spent a lot of time understanding this. And you can set this up on GitHub very easily using CI/CD configurations. But I want to like let you know about this concept, so that you can use that in your future projects. Um, the next thing is about Docker. So, which is uh, the concept I mentioned earlier, which is about um, where we used to say like it worked on my computer. Why is it not working on your computer? This is a famous meme. Like there are different variations of this, where like the version that works on your computer is not working on somebody else's, and like you can't necessarily ship your computer, right? So because of that, like this concept called Docker came up, where you build this sort of this, not it's not a virtual machine per se, but this like containerized version on a machine that has all the requirement that is needed to run this software, whether it's like the libraries, whether it likes the different languages, things like that. You'll have all of them installed, so that it doesn't matter where it runs, it can run without any issues. Like if it runs on your computer, it's gonna run on somebody else's computer, because this is Dockerized or containerized, I would say. So this is the whole concept behind Docker, which is like, as you can see, like a little bit like small containers. You containerize the entire application, the code, the environment itself together. You package that, and then it's ready to go. Um, so this is a bit of sort of examples of like especially the differentiation between Docker and virtual machines. Like you probably heard virtual machines before, especially with Python. So you have this like the machine that runs on operating system, and so you can like it runs on top of that. So the issue with that is like it's depend on the operating system. So it's relatively tied to the operating system. It's not necessarily detached from that. But when it comes to Docker, it is detached from the operating system, and obviously you can install operating system within Docker, the containerized version, but it can run on top of an operating system. There are sort of minor issues around like how you compile Docker images. So depending on how you compile it, you have to sometimes be very specific. Otherwise, it might pull certain configurations from your current operating system and build that image in a way that it wouldn't run on a different environment. So have to be a bit careful. These are relatively advanced concept when you actually try to build these. But like on a conceptual level, Docker runs on top of the operating system. So because of that, you can have these applications on different containers without disrupting other containers, and and on its own, it can run on any other environment. It doesn't matter where Docker runs, whether it's like Ubuntu, whether it's on Mac OS, whether it's on Windows, doesn't matter. It will run day in, day out, as long as you make sure that you have all the required content for that application to run, the code, dependencies, etc. So you can have predictable deployment across different environments. So that's the purpose of Docker, I would say. And this is like a sample, like a Docker file. So you have like Dockerfile within your sort of code base, so that it knows these instructions that is needed to sort of run this. So I'll sort of like explain like these commands like this. So what it says is like from Python 3 dot 10. So it's asking to get the image, Python image from Docker Hub. I'll mention what Docker Hub means. So this version has all the required libraries. It's an image that has all the required libraries for Python to run. And then we're asking to copy dot slash app. So that means I can copy so what it's starting is like you start the container with this base image, and then it's copying whatever the code that you have in your repository to that. So you need to ask it to copy that, and then you're asking it to install the environmental libraries within this, and then we are executing Python. So this is like Python space app.py. So this is how it's like it's a terminal command that's running, and it will sort of run within this container. So you have everything that is needed for this application to run on its own, and you don't have to manually set it up. And if you have um, multiple services that need to run, like if it's just backend, you'll have just need one service. But if you have a front end database service, you have backend, something like that. So it's containerized to like that you need to run together. You can use something like Docker Mesh, where it will have sorry, Docker Swarm, sorry. So you can sort of run multiple versions of multiple services in a containerized way, so that you don't have to worry about them sort of failing as well. So that's the high level overview of Docker. If you haven't used Docker, definitely can be a confusing concept. But the idea is that you sort of like package everything together, not just the code, but also the dependencies and everything that is needed for code to run independently on a different server. And you sort of like package it as an image, and then you can sort of pass it on to somebody else to run it. And if you have the Docker file, somebody else can create the image themselves from the code base, and you can run that. So that's the foundational, like the knowledge around Docker that you need to have. So it's quite important, like probably used everywhere these days, and not just the engineering projects, but anywhere else. So it's important you understand these concepts. Um, then there's Docker Hub. So the Docker Hub is predominantly extension of Docker. So as I mentioned earlier, you sort of have a Docker file, what I sort of showed you earlier, something like this. So that has the instructions on how to create your application. And then you may build it up and create an image. So this is the packaged version of your application, and you can push that to Docker Hub. So this is the Docker registry or Docker Hub, which is an online repository of all kinds of images. So other folks can use it. You can have a private repo as well. So you can have like set of collaborators use this, but also it could be a public image where everybody else can use it. And then anybody else can download this image. So you'll have the base image. So the good thing about Docker is that it is built in a way that it's like stacked in nature, so that you can get like a base image, you can add more stuff on top of that, install certain things. So you can configure it as you go. So you can start with a base image, and then you can add more stuff on top of that. So because of that, this structure works really well. So you can have the foundational image, like layers stored in GitHub, and you can sort of download this. So if I need to have like a Ubuntu Docker image, I can easily get that. So in the previous slide, I showed you that we say from Python 3.10. Um, so this is instruction for Docker to pull the Python image from the Docker Hub. So it will pull from the Docker Hub and you use that. And then if you add more instructions to make it customized for application, like things like install copying application, running requirement.txt, and you create your own image. And then you push that to a container. So the container is the location where you run the application. So you should have the Docker running locally. So if I go Docker, let me see if it pop up. So you see this like mark here, like which is the Docker mark. So it's running. So you have all these like containers running. So these are like images that are running. So I have one container running and two have been stopped. Um, so this is where you'll have your application that is running. So you can build that and it will be there. So you have the images, which are sort of the instructions on how to sort of run this. So this is like an N810 image that I've had. So to run N810 locally. So you got a lot more features within Docker Desktop. So like you could have volumes, like different types of um, sort of storage. So you've got dev environment, like some of them I haven't even used that, to be honest. But so you need to have this running locally for you to like test Docker. But the image after it's tested, you can sort of push it to GitHub and somebody else can use it. So no issues there. So you can have a version within Cursor as well. So you can integrate Docker as an extension to Cursor and you can sort of build these images very easily. But this is like the overview of Docker, I would say. Um, Docker Hub, yeah. Um, yeah. I think we luckily have time for our bonus section as well. But before I go into that, I want to like spend a bit of time, make sure that everybody is comfortable with this concept, but want to like spend a bit of time answering your questions about GitHub, CI/CD, Docker Hub. So yeah, let me know if you guys have any questions around this. Also, let me know if it doesn't make sense so that can sort of go into any specific topics if needed, or you guys come comfortable with this, no issues. Yeah. Yeah, I mean, Joy, I mean, good question. I think like, yeah, 100% like, so Docker is a must have. Like, so the more you get advanced in your career, like in your sort of the application that you build, so you need to have some, I mean, if it is not Docker, like something else that helps you containerize your sort of environment. So when you have Docker, especially, you can use Kubernetes as well. So you have like these different kinds of pods running so that, so you can have much bigger cluster running. So definitely this is the go-to sort of protocol when it comes to making sure the application that you build, like the AI engineering application that you build should be like yeah, that is like easily portable for different servers, different sort of computers, etc. So you definitely need to have Docker. So like yeah, this is like a relatively, I would say 95% of the time, the technologies that will get used, whether it's the front end, or the back end, or the models that you're building. Um, yeah, I think most of the time. I think even like only situation might be like if you have like notebooks, even notebooks. Yeah, only place I would be like notebooks that would make sense like to have Docker, but like any kind of a production grade application would have some version of Docker, like containerized solution for you to like sort of have this easily run on any kind of a application. Yeah. No, no worries. I think like yeah, I think like as long as it's a cloud environment play, definitely Docker is gonna like have use case if it's like on-prem, like if you don't want like move your code outside, like maybe it's fine. But yeah, I think like it's yeah, I mean if somebody's not using like I'm curious to know why, like what's the reason for that? Like, but like in general, my sort of gut feeling is to use this whenever possible. Like obviously, if it's like early POC, it doesn't make sense, but more you productionize the application, you probably go to some sort of a containerized version. But yeah, that's my
Yeah.
yeah startups. I guess yeah maybe no worries. yeah. Any other questions, guys, on this? Cool. This image, right? Um, yeah, I think like so here, like the idea is like you build an image, ideally should be able to run on its own. So it depends on how you sort of structure it. Like sometimes it could be just a service, or it could be like a program that's running. So ideally this should be able to run on its own. And you can sort of execute that. So you can like call like Docker run and call the image, and it will run as a service. So within any kind of a server, you should be able to run this without any issue. So that's the whole the purpose of having images. But also the other feature is like you'll have this like this image block can be used as a foundation to add more layers on top of that and create like a much more customized, fine-tuned version of your application. So that's the other side of this thing. So it's compatible in that angle as well, not just for deployment, but also to be a foundation for another application to be used. For example, if you looked at this one, so this the initial layer, this is like another image, and then you add more stuff on top of this, and this becomes the image itself. Like, so even though it started with an image, like you sort of add more stuff on top of that, and you create another image, and you can push that to Git Docker Hub, and to be another image, and somebody else can download that and like add more stuff on top of that. So the most commonly used ones like Ubuntu, Python, like any like open source solution out there will have an image. Like if you go to Docker Hub, let me see if I can show. So, so solution. So, got some random stuff here, but like, yeah. So you have like PyTorch, TensorFlow, LangChain, you name it. All these has these images. So Postgres, you can pull it out and like use it very easily. So you have like like from most of like all of the open source solutions, there will be an image that you can directly get, and get different versions. Like if you take Python, like here, you'll have different Python versions as well, so you can easily use that. Does that answer your question, Andrew? Yeah, it can run it like, yeah, so it can sort of execute this on its own. So you don't have to worry about the underlying sort of the operating system that's out there on the service. So if you have a Docker image, it can run on Windows, Mac OS without an issue. So it's like a universal package that can run anywhere. So yeah, you see. Cool. Cool. Yeah, so we'll go into the, I guess, the bonus section. So I mean, we can spend a bit of time building Docker images, but I think the final section is quite interesting. So you should probably go through that. So it's around like voice agents. So this is something very close to my heart. Like you might have seen a lot of voice agents out there, that automated calling that's happening. So this is like no connection to Git or Docker, but this is like a separate section I want to sort of cover up on this, touch up on this. So you have the text-based sort of ChatGPT type agents like out there. You got like multimodal systems like the visual like video generation models. But voice agents has been really sort of taking over the market like in the last 6 months or so. Um, so so there are two ways you can build voice agents, but the most common one is what you have. I mean, there are two diagrams. One is this one. So this is from PipeCat, and this is, I can't remember where I got this diagram from, but it's also very similar. So I mean, if you look at this one, the one in the middle, so a voice agent is like by definition is a AI voice agent, which is like uses AI technologies to mimic like a human. So if you take like a um, call center, and then like you have somebody speaking at the other end, but that person can be a voice agent, a voice agent that sort of sounds like a human, act like a human. Obviously, you can sort of tell still like if it's a human or not, but still you can get the work done. Like if you are looking for some information to try to do a booking. So yeah, I think this is quite sort of important. So I think like understanding voice agent these days, it's quite really interesting skill set to have. But if you dig a bit more, like to understand how this happens, right? So this is like the voice agent piece, right? So you speak to the agent like through your mic. You'll see like ChatGPT has this already. So this is what happens in the sort of the backend. So you have um, the voice capture. So you have the you speak to it and it becomes speech text. So you use some sort of a what does it say? Uploads connected. Yeah. You guys can hear me, right? Sorry. Hello?
Yes.
Yeah, cool. Okay. All right. Sorry. So you have some sort of model here, like for example, that converts voice to text, and then that goes to some sort of LLM, like whether it's OpenAI or like Gemini, and then that sort of goes to that text get converted to voice in the text to speech model, something like ElevenLabs, and then it becomes the audio output that we hear. So this happens real time. It generally needs to happen under 800 milliseconds. The like from you finishing your sentence to the time for the first token to generate it. So that's how we sort of calculate the delay with voice agents. So it should be under ideally 800 milliseconds. Otherwise, like humans feel that there's a delay. Sometimes it can be much faster. You should like make it add some delay so that it's around the 800 millisecond mark. So because if it is too fast, you can sort of communicate with it. So it's like a fine balance. But like when it comes to sort of like like this whole lot of science around like to understand like not science engineering I would say because like whenever you connect the Bluetooth headset there's a delay between Bluetooth and your sort of the call so like all of these things adds delays to it, so it's very important that you pick and choose the right model, the right prompt size and everything that is needed so that the voice agent development becomes much smoother. So VAPI is one of the tools out there that helps you build voice agents much faster. It's not the only tool out there. So VAPI is actually a wrapper around a library called PipeCat. So the PipeCat is one of the open source models out there that helps you build voice agents. Um, but I want to try and like show one of these like agents that you can build. So if I go to PipeCat, so this is PipeCat. PipeCat is open source, so you can go and check this. So it can help you sort of build. I mean, PipeCat is predominantly, I would say, multimodal, but they also have like you have the audio version of these a lot more rather than the video side of things. You have the speech to text models, like so it has like so it's a open source library that helps you create voice agents, so you can connect the speech to text layer, large language models, text to speech layer, and sort of get that working. Um, and so you have yeah, so Rappi did a sort of a wrapper around this, and they've sort of like built this ecosystem of this Stripe voice agents kind of um, marketplace, so that you can sort of easily go and like build your voice agents and then sort of deploy them. So I know some of you have, who in the call have tried VAPI before. If not, highly recommend trying out VAPI. So I want to like try and show quickly VAPI. Let's see. Let me see if I can log in. To, so yeah, yeah, play around with VAPI a lot. So if you go to VAPI, so like you log into VAPI, it's a cloud-based solution. So yeah, you have quite a lot of options here. So you can sort of um, do quite a lot of um, very complex agents, but I think like for us to understand, like you can go to one of the agents, like go to assistants and go create assistant. So you have um, some of these agents out there. So you can start off with um, like a custom built agent that they have. So I select one of them, like done. So you select one of the agents and you create an assistant. So so as you can see, like it is like um, structured in a way that helps you to understand what the agent can do. Like you have the model layer, you have the voice layer, you have the transcriber layer. So these are all the layers that we discussed here. So you have the uh, transcriber layer, so the voice layer, which is this piece, text to speech, and then the transcriber layer, and then there's a model layer, which is this one. And you can also connect tools. So that means if you want to call like external API, if you want to do like um, send an SMS, things like that. So you can sort of have these tools embedded. So the agent can understand this and it will invoke these tools purely from voice. And obviously, if you need compliance, there are things around that. VAPI provides that in the enterprise version. And so you can do like call logging, transcriptions, audio recording, all of these things are available. Also video recording is also there right now. So there's a lot of like nuances that like all the features, not all the features, like most of the features that you need to create like a really good voice agent. That's also like voicemail detection, so you can sort of enable that because like for example, if it is like keep waiting and like start speaking to voicemails, like it's just a waste of money. So you need to like figure out like how to like set this configuration. So you have a lot of features for your agent. So this is, I think, like yeah, like a normal agent, and you can select the type of model. So you can select from OpenAI, so you have Anthropic, etc. So you have different models from here. So this is the first message to speak out. Like this is for inbound agent, not outbound agent. So it will assistant speaks first, like and then this is the first message. And then this is the system prompt, very similar to like a system prompt that you have on like any kind of agent. You'll have a system prompt, and it will use these prompt to sort of answer your questions. And you can see those are like separated by these like hash three hashes and like structure. So so you should follow all the prompting like general guidelines here to write like a really good system prompt. And then you can have knowledge base if needed. So the max tokens needs to be smaller so that like the answers are not too verbose, so like it's like a normal conversation. um, and this is the voice configuration. So like VAPI has provided voice, and you can select especially like ElevenLabs, and from that you can sort of select like a really good voice. Let's see, can't remember what is a good one, like okay, British Mail. And even like if you custom train a model like from your voice, you can add that voice from ElevenLabs. If you select here, and you need to add your like from ElevenLabs side, which is if you haven't seen ElevenLabs before, which is this one, um, which is I mean they do a lot of things, but right now how they started was like creating text to voice models, like the audio side of things. So you can create clone your voice, things like that very easily. Like you can give like audio sample and create a voice agent, and that like voice model can be connected directly with that ID from the ElevenLabs side. But like we don't need that. We'll probably use something already out there. These are like common like common voices, and then you can select the model for the voice part. So I'll let the default configuration be. This is the transcriber, and you can select the model. Like there are different models. Like obviously, ElevenLab has, Azure has. So depending on the type of sort of the type of agent you are building, especially the language, based on the language, you can pick and choose. Like for example, um, like Google is good with like multilingual aspects. OpenAI is also good. So there are quite a few players out there. So you have a lot of features, a lot of options here to select your voice agents. And yeah, then background denoising enabled. So like if you need to filter out, like for example, if you are speaking to somebody who's in a crowd, so you can sort of have uh, this enabled, so it does some software based filtration so that the voice can be extracted. So confidence threshold, key term. So you have quite a lot of like configurations here. You don't have to like adjust everything, but like it gives you that flexibility when you want to. So it's good and bad in both ways, because like it can do a lot of things, but also like you have to learn all of these to like figure out. So you can sort of create a voice agent and then sort of um, connect this to a number, so that whenever somebody calls that number, this agent will be sort of will be answering. Let's see if I can get this to run. But I want to make sure that it can share audio as well. I think share sound. Yeah, let's see. Alex, my laptop is underwater. What can I do? So yeah, like yeah, it's like a ElevenLab agent. So you make sure that you have the right kind of settings, etc. But the idea is that you can sort of quickly build an agent, and then like you can figure out like so like how to handle like disruptions as well. Like when I sort of speak, it should like get stopped. So there are like configurations around this, like to do that, like so that like it doesn't like go on speaking like this. Like whenever they hear somebody speaking, they should stop and sort of answer you. So you have all these nuances around this agent. So you can build a very customized agent for it to be playful, different types of voice agents, voice types, etc. So yeah, this is what I want to quickly show to you guys, like voice agents. Like I know we don't have like a specific session for that, but this is like a very powerful and like very fun and like really useful tool out there with AI in the AI domain. So yeah, would love to hear about your thoughts and if any questions around this. So happy to like share thoughts around this. Yeah. Any questions around voice agents in general? Like, have you guys tried this before? Have you built voice agents? Has everyone done voice agents before? Cool, no worries. I mean, so I think like do try it like next week, especially using VAPI. Like, so create an account and see if you can create like a voice agent as well, not just what we discussed before. So I want to like hear what you guys build with something like VAPI. So for the assignment, I didn't add anything around VAPI. So, but I want to try and add something because I think like it will be fun, right? So I think like let's change the assignment. Then we'll have this one as usual. But yeah, I think like uh would be fun to like build this as well. And see like what you guys can build. So I mean what I showed you, like a very simple voice agent. Can you build something using VAPI? I mean you can use even like Google AI Builder to build a voice agent. You don't need to use VAPI. There are other tools out there. Would love to see what you guys build. And yeah, then like yeah, we got a few more minutes for questions. If there are any questions. Cool. There's a question. Yeah. So yeah, Kanishka, how do you collect the details from calls in MAPI? For example, under the analysis tab, there's summary, success evaluation, and structures there. Do you need prompts for all of those as well? No, I didn't get the question. And collect the details from the call in MAPI. So is Kanishka, you mean like getting like the information discussed during the call, and if you like get some information out? Is that the question, Kanishka? Yeah. So interesting. Yeah, I think this is like a extra, like I haven't seen this before. Like seems like way that you can summarize the content. I mean, yeah, for sure you can have that. I mean, it's not a must. I think um I think like depends on the use case. Like for example, like transcription should be enough. Like sometimes, and if you sort of connect something like make.com or n8n, like it can sort of store the information that you discussed during the call to a Google Sheet, to a CRM, so you can put that information. So you can do that, like, and you can sort of set using structured data, so you can have that. So this also has this feature I found out today. It's been a while. I played around with it. So I asked it to build like a voice agent, like in chat. It created an agent like very quickly. I just did this while I was on the train and like got it to like call me. So it was fun. Like and it called me as well. Like I mean, if I somebody gives you a number, give somebody's number, I can get this to call you directly. Like so it will call. Um, so like um, so yeah, I think like to answer your question, I think like yeah, I mean I'm not 100% sure like what it does, like, but my general sense is like, I mean, there's like plenty of features out here, like depending on the use case, you can like sort of use an external service like innate.com like to push that information to your database. Like I think that's more than enough. I think like some of these are like extra stuff, like much maybe not needed. Yeah. Yeah. Any other questions? Seems like there are no questions. All good. Sorry, what's the question? Yeah, yeah, yeah.
So
Yeah, I
get
think like yeah, so it's like VAPI is predominantly like a tool to build voice agents, so they are not sort of predominantly doubling down on building models per se. So like, so they use external models. It's like a wrapper, to be honest. Like they use OpenAI, they use like voice. I mean, they do have voice, but I think it's a partnership with like ElevenLabs, if I'm not mistaken, and transcribe models, etc. But if you want to build custom models, you can build them and then you can connect them separately. Like for example, if you go here, you can connect them via Open Router. So you can host those models and that API can be connected, and you can sort of also within VAPI, you can connect custom models and then you can sort of get them. So this is like a more like a low code, no code tool to build voice agents, but they are not proficient in building the models themselves. This is not their game. So the Quite
um,
does that. ElevenLabs does their own models, like they have their own sort of voice models. I think that's the differentiation here, if that makes sense.
yeah,
Joy, you got a question? Sure. Yeah, I'll set some times about like next week. Yeah, I'll like similar time, I guess. Like next week, I'll pick a day and like send an open invite for everyone to join in. So if that makes sense, and maybe if possible, like two as well. Yeah,
Cool.
for sure, for sure, for sure, we'll do that.
Awesome. Thank you.
Amazing. Yeah, Joy. Cool. Um, so yeah, man, as usual, like if there are questions, like feel free to ping me. And then yeah, and yeah, looking forward to what you guys build. Like hopefully see a voice agent as well. Like I think that'll be fun to see a voice agent build. And like yeah, get it out there. But if you build something, post it out there, not just to me, but also publicly on LinkedIn, etc. So like it'll be fun to see other folks try out what you build. So that's the most important thing. It's very important, like not just to build something, but also to tell a story about it. Because I know it's a bit cliche thing to do, but I think like it's gonna pay dividends a lot more. Because like peers, your friends around you may not know what you're learning, so it's very important like you get that out there, and then you sort of create a small brand around you that you know this stuff, and whenever opportunity comes up, they'll ping you and like they might reach out to you to ask questions. Yeah, that's the takeaway message from today's session. And let me know what you guys built.